Okay, now let's start section 1.1. This is chapter 1, equations and inequalities. Equations and inequalities, section 1.1, linear equations. Linear equation. What is a linear equation? Equation means you have equality, two sides, right? You have equality, and left side and right side. And sometimes in this equation you may have 1, 2, 3, 4, or even more variables. For example, you have this could be an equation. It has two variables more complex. And for our current study, we studied the equation with one variable. Current, just for this moment, one variable. And one variable, and even for one variable, you may have something like this. And you have x squared, or maybe x cubed, or x with whatever power, or possibly you have a square root of x plus, well, minus, let's put a minus. Minus 1 equal to 0. Have complex operations or higher power operation. So we don't want this. For this section, we want the linear equation. Linear equation means something like this. You only have numbers with x, no power, no special operations. Okay, this is a linear equation. And sometimes you see here, this, well, it's a clear equation. There's no restriction. If this happens, or maybe you write like x plus 2 and plus 3. Maybe it's not exactly x plus 5. You write x plus 5 is equal to x plus 2 plus 3. If this happens, it works for all the possible numbers. It's called identity. It's an identity. Identity, you don't need to solve. It's always true. If it's not identity, you check that you know that x equal to 2 satisfies the equation. Then x equal to 2 is called a solution or a root. Or, yeah, a solution or a root. You can call it a solution, you call it a root. If there's more solutions, here there's only one. If there's more solutions, you put them together. The set of all solutions is called the solution set. The solution set. Okay? We only discussed the simplest equation so far. We only studied the linear equation. Linear equation, we solve it by example. How do we solve the linear equation? In order to solve it, we will do the following strategy. We will try to keep all x in the left hand side and all the numbers, not the coefficient. 3x, this 3 is not the constant term. It's not constant, it's coefficient. This 5 is a constant term. We will keep all the x terms on the left-hand side, all the constant terms on the right-hand side. We are going to do certain movement. How do we move it? So here, you have minus 5 on the left-hand side. We will add 5 for two sides in order to cancel this negative 5 from left-hand side. Okay, so minus 5 plus 5, they cancel. So you got x, 3x. 4 plus 5 is 9. If you can do it quickly, you can ignore this line, directly say we move 5 from left side to the right side. But whenever you move across the equal sign, it changes to the plus. So that's why you get 9. Right? So if you are not so familiar with this operation, you just say let's add 5. Because here's minus 5, we add 5. If original problem has plus 5, you are going to subtract 5. You always do the opposite operation. Okay? So now you move everything to all the constant numbers into the right-hand side, and you have a coefficient. We are going to divide the equation by the coefficient of x. We always divide it by the coefficient of x. And this is the solution. Three is the solution. Okay? Okay, so sometimes it's not that simple. If it's not that simple, you're going to do the simplification and the computation. Okay? Let's see. Solve the equation 1/2 x plus 5 minus 4. Okay. Okay, so we have to know that we are familiar with the integer operation. We're not so good at the rational operations. Here you have denominator 2 and 3. You have rational number 1/2, rational number 1/3. So it give us a little bit difficulty when we do the computation. So first we try to we try to transform the rational numbers into integers. How do we do that? We are going to multiply this whole equation by the constant number 6. The 6 comes from the least common multiple of 2 and 3. Do you remember what is the least common multiple? Yeah. The least common multiple of 2 and 3 is a 6. We multiply two sides by 6. Okay, then you distribute the 6 into the difference, or 6 times it. 6 times 1/2 is 3. Well, here this is one term. You only do the product with 1/2 once. You do not do 6 times x plus 5. And that's different. You already do the computation with this term. 6 times 4 is 24. 6 times 1/3 is 2. You see, after multiplication by the least common multiple of the denominator, you transform the problem with a rational number to a problem with only integers. And now you can do the distribution. 3 times x, 3 times 5, minus 24, 2 times 2x, 2 times 1, negative 2. And then you're going to move this negative 4 to the left, and all the numbers to the right. When we move to the right, negative becomes positive, positive becomes negative. Okay, so 3x minus 4x, negative x. 24 minus 15, 9, 9 minus 2, 7. Right? Negative x is 7. You divide the equation by the coefficient of x. Coefficient is negative 1. Or you simply multiply by negative 1. Okay, so x is negative 7. Okay, so that's our operation. That's our computation examples. Remember, whenever you have rational numbers, we always multiply the equation by the least common multiple of the denominators in order to have an integer equation, integer coefficient equation. But if you have some weird numbers, not rational, clear rational numbers, for example, if we have 2.78x plus 2 over 17.931 is equal to 54.06. For this kind of equation, well, you will only do that by calculator. Well, oh, one more thing. In the exam, the calculator is never allowed. Okay, so for this, we don't do the computation by hand right now, but we just give you the idea how to do that. So first you move this number to the right side. So assume you can compute it. And second, you divide the equation by the coefficient of x. With the help of a calculator, we can compute it, but by hand, no, never. Okay. Okay, very cool. The next example. And sometimes this equation at first glance is not a linear equation. For example, we have an equation like this. 2y plus 1 times y minus 1 is equal to y plus 5 and 2y minus 5. Well, definitely from this expression, it's not a linear equation. It will have a product. You see, y times 2y is 2y squared. You will have square term. But let's see. To solve this equation, we have to do the multiplication. So 2y times y, 2y squared. 2y times negative 1 minus 2y. 1 times y plus y. 1 times negative 1, negative 1. This is left hand side. Right hand side, y times 2y, 2y squared. Y times negative 5 minus 5y. Y times 5 times 2y, 10y. 5 times negative 5, negative 25. Good. And then you see here, left side you have 2y squared, right side you have 2y squared. So they are cancelled. You have the same term, exactly the same term on two sides of the equation. You directly cancel them. It's like the balance. You remove the same item, you don't change the balance. Okay, now negative 2y plus y is negative y. Minus 1 is equal to negative 5y plus 10y is 5y. Minus 25. Now this is a linear equation. You move 5y to the left side, negative 1 to the right side. So negative y minus 5y. Here is 1 minus 25. So negative 1 minus 5y is negative 6y. This is negative 24. So y is negative 24 over negative 6 is equal to 4. So the solution is x equal to 4. The solution is x equal to 4. Right? So at the beginning it may not be a linear equation, but after the cancellation is definitely a linear equation. Another example about this type of stuff. So we try to solve this equation. The equation with a rational expression, the denominator is a function of x. Remember that whenever you have a rational expression, try to make it or try to multiply something so that to change it to the regular equations, not with the denominator. So here you have x minus 2, x minus 1, x minus 1 times x minus 2. So if we this is the equation. If we multiply two sides by x minus 1, x minus 2, you can cancel the denominator. So this is the left hand side by the multiplication, right hand side. This part directly cancel x minus 2, x minus 2, you get a 3, x minus 1. Here, this term times it. And second term, okay? So similar thing, you cancel x minus 1, x minus 1, and this part you cancel both terms. 3x minus 1, here it becomes x minus 2, here is plus 7. So it's a 3x minus 3 is x minus 2 plus 7. You move x to the left side, negative 3 to the right side, it's x, 3x minus x. Negative 3 move to the right side, it's positive, 3 minus 2 plus 7. So it's 2x is 8. X is 8 over 2 is 4. That's it. And be careful, whenever you have a denominator, check the denominator after you get the answer. X equal to 4, 4 minus 2, not 0. 4 minus 1, not 0. 4 minus 1 times 4 minus 2, not 0. Oh, it's good. It does not violate denominator, non-zero denominator property. Be careful, whenever you have denominator expression, after you get the solution, you must check the denominator. Make sure that the denominator is not 0. Okay, one more example. Okay, this one also has a denominator as a function of x. So we are going to multiply, and they have the same denominator. So we multiply two sides by x minus 1. All the terms will be multiplied by x minus 1. So this part we already cancel it, you get 3. Here, then this is x minus 1 canceled, 3x plus 2x minus 2. So 3x plus 2x, 5x, This 2 to the move to the right side is a 3 plus 2. 5x equal to 5, and x is a 1. Okay, so that's it. So to solve the linear equation is one of the simple case. You just move or keep x on the left hand side, move all the constant numbers on the right hand side, and simplify the constant numbers and divide by the coefficient of x in the final step in order to get the answer. Sometimes the equation does not look like a linear equation. Do some transformation, do some computation, cancel the denominator, make sure it look like a linear equation. Okay, very good. This is our first day class, and we finished the chapter section R1, R2, and we finished the section 1.1. Do the exercise. Ask me question if you have. Okay, thank you. Bye bye.